Today's the 6th. I know, right? So we are starting unit 4. I should be able to get through this unit like twice as fast as I got through the last unit because um, I think personally that a lot of unit 4 is going to be stuff that comes back to you from unit 1. So back in unit 1, we did um, synthetic division. You'll remember that with polynomials where we chip away and then we get quadratics and we set them equal to 0. It's been a long time, but I think a lot of the skills from that unit overlap with this one, so we shouldn't have any major issues. So, anyways, this is unit 3, and basically the entire unit 3 is just revolves around quadratics. And just remember, in case you've forgotten what a quadratic is, which I wouldn't be offended if you had, but a quadratic is just any sort of expression or equation or function that has x squared as its highest power. So x squared plus 5x minus 9, negative 3x squared plus 19, whatever. If it's got x squared and no x is higher than that, then it's called a quadratic. So that's what we're going to focus on here. So just quickly, a few sort of let's make sure kind of things before we get into the lesson. Do you guys remember how to simplify square roots? I was going to do a whole day on this and I was like, nah, they don't, what would be a waste of a day. So do you guys remember how to break down a square root? Some of you like to do it this way. I'll show you this way and maybe it'll come back to you. How we make a little tree. It's 4 and 2, right? So we go as long. I mean, you should never have to go more than one step, ideally, but we always want to make sure we pick two numbers, and we want the first one to be square rootable, and then we want the second one to not really. We don't want the second one to have any meat left on the bone. And then what's the square root of 4? So we would express the square root of 8 as 2 root 2. How about this one? How about like the square root of 32? 4 and 8 would work, but you'll remember that the trouble, yeah, 16 and 2 is the money one. The trouble with 4 and 8 is that 4 is pretty rad and it gives us 2, but the rub there is that 8 still has meat on its bone, and then you'd have to break down 8 again. And so what we want to avoid is having to do multiple steps. The trees can get pretty hectic. So what we want to do is go back and say, no, 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 let's go bigger. Let's find the biggest number that's square rootable that goes into 32, and that's 16. You remember that. So that becomes 4 root 2. Is this coming back to you? And then every once in a while, we see square roots like this, that where we don't try to make like a tree, right? We just know what's the square root of 81. Like it's just 9, right? So you don't always have to make a tree thing, but you guys remember how to break down radicals like this? Okay, so another thing that we have to make sure that you're aware of, and I'm just going to kind of blow right by this one because I feel like, again, this got covered in Unit 1, is if you get a quadratic equation like, say, this. One of the most common ways that we like to solve quadratic equations is by doing factoring. And we started unit 1 actually this year with that big beast of a factoring unit. So sometimes you can look at a quadratic like this and you set it equal to 0, and then you try to factor down the left side. So if you factor the left side, it factors down into x plus 5 times x plus 1. Right. So it'd be pretty old hat for you guys. And then the answers to this equation would be the numbers that make the factors equal 0, right? So like negative 5 and negative 1. So we have the benefit coming into this chapter, this unit, of saying like, we've done this before. You know how to solve equations by factoring. And then the final sort of prerequisite to this is, what do we do with a quadratic equation like this? Do you remember our bailout method when we can't factor it? Because you can't factor this, right? You could sit here all day and try. Right. And so again, we're at the advantage, we're at an advantage in that we know the quadratic formula. The quadratic formula is the thing, remember, that enables us to solve quadratic equations when factoring is not something that is either possible or maybe it was possible and we just didn't see it. But what's nice, remember, about this negative b plus or minus the square root of b squared minus 4ac all over 2a is that it always works. 100% of the time, the quadratic formula works. Some would say it's the best. I wouldn't necessarily disagree with them, only just because it always works. The trouble with it is it's not always the most efficient route from point A to point B. So like in a case like this where factoring fails us, then we would just take the numbers. Remember that A is right here, 1, B is right there, -4, and C right here would be 2. Is this all, am I correct in assuming that these are all things that are in our familiar zone? Okay, so that was, all of this was sort of, I was able to, in my mind, to think like, we don't need to take a day for this and a day for this, because like we've been down all these roads before. What I wanted to show you today, and I apologize if I've shown it to you before, like I said, my my brain, my professional existence, my different classes and my years and semesters, they all start to bleed together and I kind of lose track. Is the third method for solving quadratics. It's when it works, it's unquestionably my favorite. And the trouble with completing the square is that it's a pretty niche thing. Like you don't want to try to do this method under certain circumstances. And this won't take too long, I don't think, but I'll talk to you throughout the lesson about, and you'll figure it out yourself too. Like when is completing the square a terrible idea? And you'll piece the puzzle sort of together, but I'll help you with that process. So completing the square, I'll show you how it works. Before I show you how the method works, there's a little bit of a sidebar here. Let me ask you this. Oops, that's not a 5. My bad. Forget the 0 for a second. We don't need to like equals or anything. Let's just practice factoring real quick because I want you to notice something about this. Like not all quadratics are created equal. If we factored this down, what would it factor down into? X plus 5 times x plus 5, right? Which we would write as x plus 5 squared. So this is called a square. And the idea behind it is that I know it doesn't look like a square, it looks like an oval, but I'm talking about that mathematical expression. Something like x squared plus 10x plus 25 is called a square. And the reason we call it a square is for the exact same reason that we call 4 a square. Why is 4 a square? Well, because it's 2 squared. Why is 100 a square? Because it's 10 squared, right? Why is 81 a square? Right. And so that's why I can call x squared plus 10x plus 25 a square because it's something squared. And so we want to think about polynomials that look like this. And we want to think about how can we make something look like that if it doesn't look like that. And so if I gave you something like this, and then I put a blank here, and I ask you to put a number there that would turn this into a square. In other words, like, listen, by the way, there's lots of numbers that I could put in here, and don't write this down. But like if I put -32 here, I could factor this into x plus 16 times x minus 2, right? Whoop-de-doo. But what I want is I want to put a number in the blank that makes it so that when I factor it, it factors into something squared, right? So what is the number that I need? It is 49. Very good. And so if I put a 49 right here, then I know that when I factor this down, it'll factor into x plus 7 times x plus 7, which is x plus 7 squared. So what you just did by saying that number 49 is you just did something called completing the square. You put a number in here that completed the square. Is this looking familiar to you? Okay, I mean, I didn't know what I'd get there, a resounding yes or no, but I feel like we were in the right spot. This is good. So that number can be arrived at. It's not a guessing game. It's not a trial and error game. The way the 49 comes into existence is by a formula. It's a very quick and easy formula. You take the number that's in the middle, which is 14, and you divide it by 2. What's 14 divided by 2? It is, and then square that, and what do you get? And that's the number that you'll always use to complete the square. Okay? Let's practice this again. So let me give you another polynomial, x squared minus 12x blank. 36 is our guy. 36, listen, again, there are literally infinitely many numbers you could put in that blank that would still make a factorable polynomial. But to make it factor into something times itself, you have to follow the algorithm. And the algorithm says you take half of the number in the middle, which is negative 12, and you get negative 6. And when you square negative 6, you get positive 36. Will the number that I put in the completing the square blank, will it always be a positive? It will. Why? Because we're squaring something to find it, right? So regardless of what the middle number will matter, as you'll see in about 2 minutes. But for this process of actually completing the square, it doesn't. Whatever we get, we put a plus because it's something squared, right? So that is how you complete a square. Let's do one more. What number goes in the blank? Plus one. Very good. And again, it's just a formula. It's never up for debate or like negotiation. Half of negative 2 is negative 1, and negative 1 squared is positive 1. Boom, you completed the square. And you could prove that it's a square by factoring it into x minus 1 times x minus 1. So you'll notice something about all of these problems, and I sort of alluded to this a while ago, that completing the square works well when it's supposed to work well. Negative 2, negative 12, and 14. What do they all have in common? They're even. And why is that important? Correct. And so I won't ask you to do completing the square right now, today, when the number in the middle is an odd. Because if you take half of an odd, you get a fraction. And it's not the end of the world. Like, it's still totally doable. It just sucks a little bit more. So do pay attention to, if I'm any good at this, when we're done, you'll know how to solve quadratics ideally, and you'll know exactly the right way to do it. If you see one that's factorable, a smart person says, I'll factor it. If you see that it's set for completing the square, you'll use what you're going to learn today. Then if those two fail, then you're like, all right, I guess I'm going to use my old buddy, the quadratic formula. So that's sort of the flow of how it's supposed to go. Like, your checklist is always look for factoring because it's always the quickest, and then see if it's good for that little niche method, completing the square, and then just use the quadratic formula when all else fails, right? Okay, so let's look at the actual process of completing the square and how you do it. So here is a quadratic equation. And what I want to do today is not have you thinking about factoring, okay? There's going to come a point where a few days from now where I start sort of trying to tell you, let's think smart about what method we ought to use. I'm going to bully you a little bit today and tell you we're going to use completing the square. Today, there's a little worksheet with 8 problems, and I just want you to practice this skill. So you'll see that some of them in hindsight could have been factored. You'll see that that's fine. But the point is, like, we're not going to even look for that because I think half of these or so could be done by factoring, but I want you to see what it looks like when we overlook the factoring and use completing the square. I want you to see what the results tell us. So here comes the process. This is the part of the notes where you want to be really deliberate about step 1, step 2, step 3. Like, it's a very laid out, like, concrete process. So the first thing we're going to do is we're going to move this 71 to the other side, and we're going to leave a void after the 2x. So just like we did in about 3 or 4 minutes ago, I'm going to set it up like this: x squared plus 2x blank. And then to move the 71 to the other side, I have to add it. So I get 80. So you want your completing the square problems to look just like this. Be very deliberate about that space. That should be there. It should be big enough for you to put a plus sign and a number into. All right, so we ignore the 80 for a little bit, and then we just follow the algorithm that we talked about a few minutes ago. What number is going to go in the blank? Correct. Half of 2 is 1. 1 squared is 1. So we're going to add 1, and that completes the square. Now, in math, what you learned a long time ago, long before probably you met me, is that, like, the number one rule in algebra is if you do something to the left side on the equal sign, you got to do it to the right. So we're going to go over to the other side, and we're also going to add 1 so that we don't mess up the balance. You still with me? Okay, good. And now what we're going to do is we're going to factor the left-hand side. And when we factor it, we're not going to factor it into x plus 1 times x plus 1. We're going to factor it into x plus 1 squared. And then on the right side, we're going to just do the math. Whatever the math is, we do. Any issues so far? Okay, the next step in this is to get the X out in the open. X right now is in jail. It's in this little tiny jail cell and it can't go anywhere because it's like, you got to free me, but I got this exponent up here, this 2 that's holding me in. And so as mathematicians, we have a tool for literally every job. I mean, my job and the teacher after me and after me and after them and after them is just to continue to fill your toolbox with different things that you can use to do different projects. Can you think of a way to kill this exponent? Correct. So we're going to square root this side, and we're going to square root this side. The act of square rooting cancels out the square, and just like that, the x and the plus 1 find that confinement lifted, and they're free. There's no more group. There's no more exponent. It's just x plus 1 out in the open. And then usually, I would say the most common error that I see with completing the square is people say, oh, the square root of 81 is 9, which it is. But if you've ever seen anything like this before, you know that in a case like this, the square root of 81 has 2 answers. It's not just 9. What's another number that is the square root of 81? Correct. So you have to put a positive negative sign right at that point in time. The moment you do the square root step, right after that is the moment you insert the positive negative sign. And that's where the quadratic yields its 2 different solutions. Quadratics, of course, have 2 solutions, and that's where we find our opportunity to find them both. So now all that we're left with is to move the 1 to the other side. So we're going to move the 1 to the other side, and we're going to have x equals -1 plus or minus 9. Now, there are 2 pathways that we have to travel here. One of them is called, well, plus, right? And the other pathway is called minus. And so we trace the pathways independent of each other, and that's where we'll get our answers. So if you take the red pathway, what is -1 plus 9? So one of our solutions is 8. And if we take the yellow pathway, what's -1 minus 9? Correct. And I just want to show you the connection. And again, I said I don't want you doing factoring. I just want you to piece the puzzle together. Way back at the beginning, had I taken this equation and I moved the 9 to the other side, I would have gotten x squared plus 2x minus 80 equals 0. And I could have factored it into x plus 10 times x plus 8. And that's where the solutions x equals -10 and x equals +8 would have come from. So the connection there for you as a student is to say, okay, when I get answers like this that are just nice little easy, happy, go lucky numbers, yeah, I could have factored it. But like Bossy Britches up here said, I don't want you factoring today. Good? Okay. All right, let's do another one. So let's see if you can piece it back together. What's step 1? Boot the 12. Good job. So we're going to have our x squared and our -8x. We're going to leave a deliberate void and then move +12 to the other side. And then you just follow your own little algorithm. We got that really quick today, by the way. That was a good job. What's half of -8? What -4 squared is? +16. So I'm going to add 16 to this side, and I'm going to add 16 to this side. The square is complete. It's where it gets its name. You just literally completed the square. But now we have to cash it in, right? Like make good on what you did. So what does the left side factor down into? X minus 4 times x minus 4, which is x minus 4 squared. I will tell you this, here's a little gem for you, for people that listen well and absorb when I say something and they absorb it. people that are, you said this, you said this. You see this minus sign in the middle? It will always be the same as the one in your square. Okay? So the middle term will get mimicked when you factor the square. And then, of course, you got to do some little second grade math over here. What's 12 plus 16? Is correct. Good. And now what's the next step? Square root both sides. All right. So first we have to free x and minus 4 from their little prison. And so if I square root the left side, I get x minus 4. And if I square root the right side, I get positive negative root 28. And I started the lesson today with just a quick refresher to make sure that you had not forgotten how to break down square roots. So let's go off to the side because 28 is not like 81. That last problem, 81, was like, well, 9, dude. But the square root of 28 needs a tree. So what are we going to use for 28? Nah, 4 and 7. Yeah, 9 and 3 make 27. I know. That's all good. So the square root of 28 in its mathematically acceptable form is 2 root 7. Okay, so I'm going to do a couple things at once here. Number one, I'm going to move the 4 to the other side and put 4, positive 4, of course, plus or minus. And then I'm going to change root 28 into 2 root 7. And I'm going to put a box around this, and I am done. Someone read me just one of my answers. What's one answer? Just one. There are 2 in the box. Read me one of them. 4 plus 2 root 7 is one of the answers. What's the other one? 4 minus 2 root 7. Those have decimal values, like they're real numbers. They're not weird things. They're just irrational, but they're still just normal numbers. Okay. Let's do a couple more. Make sure that we get all the kinks worked out. I'm going to switch variables because the worksheet's going to have different variables. So I'm just going to use some different variables just so that you are accustomed to that. I don't want you to think it's always going to be X. I use X a lot, but the computer program that I use to generate worksheets, a lot of times it just goes, woo, B, V, M, R. It does whatever it wants. So it doesn't matter. It's all the same. Step 1, what do we do? Move that 1. You get n squared minus 6n. Leave a space equals what? 2. Perfect. And then we follow the algorithm. What number goes in the blank? No. Plus 9. Add 9 there to complete the square. Add 9 here to not anger the math gods. Remember, keep the balance intact. Don't mess up the juju. And then what does the factoring on the left side over here produce? N minus 3 squared. Correct. Good job mimicking the sign. So again, you picked that up. Whatever sign was in the middle of the original factorable is going to be mimicked, copycatted down to the middle of the square. And then what is 2 plus 9? 11. It's actually good news because 11 is like, you'll see here in a second, 11 is just done. 11 is a trash number. It's not square rootable. It's not even reducible. So that'll actually save you time. These wind up being our favorites because like there's no extra work. So you can go as fast as you want. I'm going to not skip a step, but you will find yourself at this point starting to do 2 things at once. You'll square root while also moving the 3 to the other side. I'm just not going to. So we're going to get n minus 3 equals what? Positive or negative? Not 11. Root 11. Got to take the square root at that exact point in time. And then, like I said, you get good enough at this that you start also moving that 3. But so this is what it looks like. We get n equals 3 plus or minus root 11. And you will notice, and I'm not going to pick fights about this because I just don't care that much, but can someone read what's in the green to me? It's called a positive negative. And the reason it's a positive negative is because there's nothing in front of it. So it's not yet a verb. It's an adjective. Positive negative is a symbol that represents whether a number is positive negative. The moment you move something in front of it, it now becomes a verb. And we no longer say it as positive negative root 11. We now say plus or minus. So that'll not going to be something I split hairs about. I just thought I would tell you. So if there's nothing like when you read this number, you say -4, right? No one says that. Ooh, look, I put a -4. No one says that. But if you put something in front of it, now we say 10 minus 4. So no big deal. All right, one more. Let's make sure you're good, and then I'm out. M squared minus 14m plus 24 equals -7. Move that 24. Leave a space. What'll be the number on the right? -31. Good. And now when we complete the square, we will put plus 49 because that's half of -14, which is -7, which squared is 49. And you make sure you just do it to the other side, right? That's the key. And then you factor. What does the left side over here factor down into? -7 squared. And what's -31 plus 49? 18. And then we do our thing. So once you reach expert level at this, you will go like this. But you will get there when you're darn good and ready. You will write the final answer as m equals 7 plus or minus 3 root 2. If I do stuff like that in a lesson, people get really upset. And so I'm not going to leave it. I'm just telling you that you will get to that point where you start just snapping to the final answer and you have my full support. But to take our time, this would look like m minus 7 equals positive negative root 18. And then you go over here off to the side and you break this down. What numbers break down the 18? 9 and 2, which becomes 3 root 2. And so then you have m minus 7 equals positive negative 3 root 2. I couldn't show any more work on this problem if I tried. But again, if you get to a point where you will just start skipping from here to here, and I've got no issues with that whatsoever. Okay. Do you have any questions about that process? Roughly half of your answers today will come out like regular numbers, and then about half will come out as like this with roots on them. No questions? Rad.